So good afternoon everybody, myself Acharya Vishvendra, and today I'm going to discuss some of the concepts, basic terms, basic formulas related to the projectile motion. So let's begin. Suppose this is a projectile, it is projected with the speed u at an angle theta with the horizontal, and suppose it follows this trajectory and finally lands with a speed v at an angle theta. So let's analyze different parameters related to this. So the first question is initial velocity along x-axis, so it is u cos theta. Second is initial velocity along y-axis, it is u sin theta, as you can see over here. Next is time of ascent, that is time taken to move from point O to point A. So it is u sin theta by g, and it can also be written as velocity along y-axis upon acceleration along y-axis. Next is time of descent, that is time taken to move from A to O. So this is also u sin theta by g, or we can write it as uy upon ay. Next is the time of flight, that is time taken to move from O to B. So it is twice of this time of ascent or the time of descent. So that will be 2u sin theta by g, or twice of uy by ay. Next is maximum height. So this is equal to u square sin square theta by 2g, or uy whole square by twice of ay. Next is horizontal range. So horizontal range is 2u square sin theta cos theta by g, or this is also equal to twice ux uy upon ay, and this can also be written as u square sin 2 theta by g. Next is the ratio of h and r. So if you put the formula above, it comes out to be tan theta by 4. Next is at what angle h is equals to r. So h by r is tan theta by 4. You substitute h is equals to r. So from here we get tan theta is equals to 4, or theta is equals to tan inverse of 4, or about 76 degree. Next is at what angle h is greater than r, or h by r is greater than 1. So if h by r is greater than 1, then tan theta will be greater than 4. That means theta will be greater than tan inverse 4 or 76 degree. So for angle greater than 76 degree, height is greater than range. Next is at what angle h is less than r. So h will be less than r when h by r is less than 1, or when tan theta is less than 4, or when theta is less than tan inverse 4 or 76 degree. So these are the analysis related to this. Now another concept is x coordinate as a function of time. Suppose at a given instant particle is at p, its x coordinate is x, y coordinate is y. Then x coordinate as a function of time can be given as u cos theta into t, where y coordinate as a function of time, using this equation we get displacement as y minus 0, substituting acceleration as minus g. So we get y as u sin theta t minus half gt square. Next is equation of trajectory. So we just eliminate time from here, from the first equation. So t comes out to be x by u cos theta. Now we substitute value of t in this expression, and from here, after substituting the value, we get the final result as y is x tan theta minus gx square by 2u square cos square theta, or it can be written as ax minus bx square. Next is, if trajectory equation is ax minus bx square, find a range. So we can see that at x is equal to range, y is 0. So we substitute y is equal to 0 over here, and we get 0 is equal to ar minus br square, which gives r as a by b. So if equation of the projectile is given in this form, then the horizontal range is a by b. Next is find maximum height. So the vertical equation is y is equal to ax minus bx square, and we know that the graph is symmetrical. So at maximum height, x is equal to r by 2 and r is a by b. So x is a by 2b. If we substitute for y after the calculations, we get y as a square by 4b, which is expression for the maximum height. Next is find angle of projection. So we know that a is equal to tan theta. So from there theta comes out to be tan inverse of A. Next is there are 2 points. Suppose there is a point whose height is is h. Its distance from the origin is x1 and from the range is the point of projection is x2. We need to find the relation between h, x1 and x2. So using equation of trajectory as y is x tan theta 1 minus x by r, we substitute y as h, x as x1. So after the calculations we get h is equals to x1 x2 tan theta by x1 plus x2. So these were the basic concepts and basic facts related to projectile motion, and in this single question we have taken 18 the information, the facts which are related to the projectile motion. The purpose behind this video is to optimize your time and energy and to prepare topic in a very few minutes. As you can see that in 6 minutes we have revised most of the things, most of the basic concepts, terms, facts related to projectile motion, covering from the very basic level questions to gradually moving the advanced questions. In another worksheet we will complete up to NEET PYQ, JEE main PYQ, and even up to JEE advanced PYQs, because in these exams the questions are just a manipulation of mixture of the basic facts. So we can prepare the entire topic within a few hours. It's easy to retrieve and you have a good chance of scoring good in exams. Thank you and have a nice day. If you have any doubt, you can ask in the doubts comment section. Thank you and have a nice day.